Right, morning everyone. This is a talk about managing OpenWRT devices from the cloud, or OpenWrt, as someone has told me this morning that it's supposed to be called over here. Yeah, so I'm Simon Morley, or Tony as I've now become known at this conference. Thanks for that, Scott. And yeah, still I'm the least qualified man in the room to talk about wireless, so I'm going to avoid all of that stuff. Over the last couple of days, yeah, I've been asked loads of questions about this, so I've kind of shoved everything in this talk and I'm going to race through it. So if you've got any questions, come and talk to me afterwards, and I apologize because it's an unfinished presentation completely. So quick overview. Does everyone in the room know about OpenWrt, or not at all? Yes? Most of you? Yeah? Okay, so well, in summary, it's an open source operating system for embedded devices, a typical console login. So it runs on a pile of different manufacturers' devices at the moment. And then we started this project probably 4 years ago internally, and then really we kind of launched in June last year, but we've been doing it for quite a long time. And the kind of rationale was a few years ago that we had a pile of different boxes from a pile of different manufacturers, and actually none of our customers were actually using any of the features at all. So it was kind of 20% of the features they were using Meraki boxes and had no idea what any of them were actually for. So we thought we could take the 20% of those features and turn it into something that was actually useful for everyone, kind of thing. So we wanted the boxes to be completely independent from the kind of cloud dashboard. We wanted, if anything went down, we wanted them to be able to function happily. We wanted to be able to send changes to the boxes in like under a second. So if you had 1,000 access points, you could push and change SSID, and the rest would be taken care of. And actually, from the talk yesterday, I'm quite keen on choice. So we wanted, obviously, we needed to flash these boxes with a firmware, but we wanted to give people the choice to roll back to like the manufacturer's firmware, or just vanilla OpenWrt or DDWRT, whatever they wanted. And then the biggest thing that we wanted to do was make sure that regardless of the box, sorry, we call them boxes, not access points, that's just an internal thing. We wanted them to have the same feature set, so it was built into the kind of dashboard. So if it's a TP-Link or an Ingenious or a Unify, they all had the same kind of feature set. And then I think we had a bit of a meltdown last November. We got asked to go to the Open... Someone got a laugh, you know who these are. We went to the OpenWRT summit, and I was kind of flying over there with Andrew. There's only 4 of us in the office, and Andrew's my kind of chief Wi-Fi ninja. I realized on the plane that we actually had spent like several years in this darkened room together, so to speak, writing this software, and I had taken no external advice or opinions about whether to do this or not, and how to do it. And I was like, what if we turn up in front of these like 200 nerds and have built the most ridiculous thing in the world? So we sat there through about 20 talks, and throughout the day, the interesting thing was that all of these people, like managing OpenWRT boxes and developing OpenWRT, had had the same kind of problems. They'd just gone about it the other way. So they'd put tons of memory in their boxes, whereas we didn't have tons of memory, so we took all the processing and put it in the back end kind of thing. And testing, for instance, was another big thing. They'd built like racks and racks and racks to put their boards on, but we didn't have that also, so we ended up testing it in the kind of code instead. So I'll talk about that in a bit. This is the IT crowd, by the way, if anyone's not see them. It's something to watch. So at the moment, like, we can run it on like a selection of devices. Obviously, the Meraki MR12s, 16 and 18s was an accident. We didn't do that, but it's convenient. And the future holds, we want to release it on any OpenWRT device. So not just our ones. And then this is, we wrote a little package called Socketman. Obviously, the naming thing with us seems to be a bit of an issue. So Socketman is our kind of in-house package. It's like a 25K program. We wrote it in C, and it runs on OpenWRT, and it listens for changes. So there's no crons or anything. It's just listening all the time for stuff. So you send a job to it, it listens, it does it, and then it will send a response back. And that's, at the end of the year, we're going to open source this so that anyone can take it, anyone can install it on OpenWRT and actually benefit from what we've done with it. So moving forwards, so this is, if any of you have used it, like this on the left-hand side is a traditional kind of OpenWRT wireless file. On the right-hand side is actually one of our wireless files. So we decided, because we didn't have this kind of test rack, we didn't have the ability to test all the boxes all the time, that we would kind of redefine the way that the network files are built. So in Qcombetoni in the back end, that's the file, and then we build the file up line by line in code. So this gives us the opportunity to actually test on our servers. So instead of testing on hardware, we test in our kind of environment. So we test the code, and like I said, I'm a programmer, so I've kind of come at Wi-Fi from a programmer's perspective. So we test it, and then we deploy it to a set of continuous integration servers. They retest it, they deploy our code, and then it's done, basically. A couple of you in the room have used our boxes, and I'm pretty sure that you've probably also found bugs, and I think that's the thing we're trying to do with this. It's when we fix a bug, we can do it in about 25 minutes, and we can push the changes, and then usually there's no need for a firmware upgrade. It's just kind of done and dusted. I've got nothing to say about that, really. That's a shelf of equipment. I've also got nothing to say about that one, because that's basically what we're trying to do. So instead of deploying like once every 4 months, we deploy about 4 times a day at the moment. So it's loads and loads and loads of small changes, and then it keeps it reliable and it keeps it fast. Yeah, so I guess that's Tony. So moving on a little bit further, so because it's kind of, it's not hardware stuff, it's software stuff, we can do kind of what we think is clever things. But so the Lucky Dip is one of the tools that we've got internally. Do you have Lucky Dip over here? Okay. Can someone translate? A Lucky Dip is like a raffle, so you go in and get like it's a raffle, basically. So each one of our customers is assigned like a number 1 to 100, and each box is assigned a number 1 to 100, and each location is assigned a number 1 to 100. And then when we're rolling out new features, because it's likely to break all the boxes, we didn't want to roll out 5,000 boxes, 5,000 changes, so we assign a number to each feature request. So we'll only assign 10% of the boxes or customers will get a new feature, so only 10% break our system kind of thing. So actually it's not a lucky dip, it's a very unlucky dip. And then the other bits and pieces that we've got, because again we've moved all the logic back into the back end, we can do what we call like triggers. So these are events or triggers based on stuff that happened. So the basics were just silly things like a box goes offline, you can send a trigger out to like Slack or something like that. And then we decided that it would be cool actually if you could do other things. So when a client connects to a box, you can send a trigger out that will fire off an SMS or something like that. And then we're moving forwards with the kind of IFTTT thing so that you could have a proactive kind of service. So one of the guys in the office came up with an idea: if he didn't go to the gym 3 times a week, then he could get Zapier, for instance, to slow his broadband down or his Wi-Fi down. So he's getting quite fat at the moment, and his broadband's really slow. So, and then a couple of you have asked about what's the future of it. So, I mean, it's a very new product to us. We're very small. We're not entirely sure. Well, we're not business people, so we're not sitting there with a business plan figuring things out. But I guess from my point of view, like if we can open source Socketman, you can all use it. You can all install it on your OpenWRT boxes if you want. We want to separate out the management of Qcombetoni from the front end. So we've built a nice API that people can use, but then we want to take out the kind of transport layer that we've built. So if you had a large network of boxes, you could just capitalize on the tools that we've built there. And that kind of ties into the customizable configs. If you can send, at the moment you can only send like predefined scripts to boxes effectively, but we'd like people to be able to send anything to a box, be it a network file or a config file for something else. And then I was talking to this guy down here the other day about kind of learning from the data that we've got. So all of the data that flows in, we get it every bit of data every 45 seconds from every box and every client. And we were trying to work out whether we can actually do something intelligent with this. So can we use the TX and RX to predict something in the future? So yeah, that is me.